In this segment, we're going to introduce you to core concepts that we're going to use over the next few weeks when we talk about trade space exploration. Let's start off by talking about a decision problem that many of us face in our lives. Perhaps we're entering a new phase of our life and we're trying to figure out where we should live. One option is to choose an easy solution. At my parents' house, I can live with them, it's free. Or is it? Thinking more deeply about this, I realized that even though I may not be paying any dollars to live with my parents, it's actually quite stressful to live with them. This brings up an important point. That is, when we think about the costs of our alternatives, they're often multi-criteria. In this particular case, cost is more than just dollars. It includes stress. Perhaps instead I want to consider a different alternative. Maybe I want to buy a new house. Well, in considering a new house, that's going to be quite pricey. You have to pay a lot, but it's not going to be stressful. But I care about more than just cost. I care about the benefit as well. Why would I pay a lot of money to have a new house unless I was going to get something for it? In this particular case, I want to buy a new house because I want to have a nice, large place to live. I don't want to live in my old bedroom any longer. I also care about how far I have to commute to work. Turns out my parents' house is pretty far away. In this case, just like cost, benefit is a multi-criteria consideration that I care about. I care about my commute distance, I care about my comfort, I care about the noise of my neighbors. In this example, living with my parents is a low-cost, also low-benefit alternative. It's far from work. And buying a new house is a high-benefit, high-cost solution. This brings up an important aspect of decision problems. When we propose multiple alternatives, we often discover there are trade-offs among the different criteria we care about, considering how they fall between benefit and costs. Now we can identify patterns. There are two key types of alternatives in this representation. We have the Pareto front, which are our most efficient benefit at cost alternatives, and we have the dominated alternatives, those that are not on the Pareto front. These are the solutions that are inferior in terms of benefit or cost as compared to other alternatives. The Pareto front represents the highest benefit for a given cost or the lowest cost for a given benefit alternatives. These solutions are the ones that exhibit the core trade-offs that we're going to have to consider when deciding which alternative we like the best. Another thing we can consider in this representation are budget constraints. These represent the maximum we're willing to pay in terms of cost for picking an alternative. We represent this as a vertical line in a benefit-cost trade space representation. Anything higher than the budget constraint is deemed infeasible and no alternatives there are attractive. Below the budget constraint, these alternatives are feasible and are potentially good solutions. Additionally, we can think about desires constraints on the benefit axis. These might specify minimum acceptable levels for things like square footage or commute time. In this example, anything below the desires constraint would be deemed infeasible, and anything above that would be deemed feasible, potentially attractive. In this representation, we can see there's a quadrant that's left over of acceptable and attractive alternatives, but there's still a trade-off that exists along that Pareto front. Picking a particular alternative along the Pareto front is a subjective judgment call that the decision maker needs to make. There's no right answer, at least in this representation. In this example, a shared condo is the higher benefit, higher cost alternative that I decided to go with. Now, even for this very simple problem, using this representation was a very powerful way of thinking about a structured means for solving our decision problems. That is, in general, we define a problem, we derive criteria, we propose alternatives, we evaluate those alternatives, and then we assess those alternatives in terms of whether they meet our constraints and whether there are good enough solutions in there that I'm willing to select one and walk away. The objectives and goals can be derived into criteria for evaluation. These are particular metrics that we're going to evaluate using different modeling and simulation techniques and/or other means for generating data. We often call these attributes as an operationalization of criteria that represent value. For example, what's the revisit time of my satellite? What's the miles per gallon for my car? We use these value criteria to propose possible solutions. For example, where should I live in the prior example? Or what type of car should I buy? Or what should be the design of my satellite system for performing this mission? There are many different ways of generating alternatives that we'll talk about later. One particular consideration is the number of alternatives we generate. We can look at one, perhaps that's a good solution. We could look at a few, which begin to give us some insight into different trade-offs that might exist. Or we could look at many possible solutions, where we could begin to see the trade space amongst the many criteria that we care about. The value proposition that we're trying to evaluate, such as where should I live, may actually change over time or be context dependent. Having a structured framework for considering these things allows us to deal with that extra complexity. Additionally, we can get deeper insights into the relationship between what I want and what I can actually get. One of the techniques we're going to talk about in the coming weeks is multi-attribute trait space exploration, which is a structured framework for thinking through a decision problem and proposing solutions. It allows us to look at a large number of alternatives and understand the relationship between different values I might have and what I might be able to achieve technically. Additionally, it provides a very useful mechanism for communicating among different stakeholders to identify trade-offs between what people ask for and what's technically feasible.